Ah, okay, cool.
There it is.
Perfect. Hi, everyone. Good afternoon, good morning, good evening, wherever you're joining in from. Thank you so much for joining us today for this webinar. Super excited to have you. My name is Kennedy Torkura. I'm one of the founders here at Mitigant and also the CTO. Just a little bit about Mitigant. If you don't know about us, Mitigant is a cloud security company. We are based in Potsdam, which is very close to Berlin, and we do all different kinds of aspects regarding cloud security, from KSPM, which is looking at the Kubernetes environments, looking at the cloud, looking at offensive security like cloud attack emulation. So today we are for this webinar, we're going to be talking about a very interesting topic, looking at unmasking and cloud AI attacks. We'll look at the attacks, we'll look at the defenses, how you can protect yourself. And I want to mention that the session is going to be something roughly between 30-40 minutes. And we will also have a questions and answer session afterwards. So if you have any questions, feel free to just, you can actually drop them in the chat right away, or you can just have some patience at the end of the presentation, where we go through all the questions and try to answer them. As also the session is being recorded, but we're going to stop the recording just before the Q&A session, so you can feel free to actually speak or talk and without any fear at that time. Okay, so without wasting time, I'm going to be inviting our guest speaker. So our guest speaker today is Rico Komenda, and he's going to say more about himself, but just to make you know that he works at Adesso. So if you don't know Adesso is like more like the KPMG kind of big consultancy, one of the biggest in Germany. So he has loads of experience, and today we have the opportunity to tap into some of these things he has seen. So without wasting time, Rico, the floor is yours.
Thank you, Kennedy. Glad that we are talk together, because I think the first time we met was January this year at NDC Security,
Yeah.
and I'm glad that we are doing a talk together now. Yes, hello to all of you from me. As Kennedy said, I will also leave some words about me and some additions to Kennedy about adesso in the next slide. Just let me move to the next slide. So who am I? My name is Rico Komenda. I'm a senior security consultant at Adesso. Adesso is a software development and consulting company based in Germany, but all over all over Europe. That's for the SE. So we are Societas Empritatas, I think is it called. For every business line you know of, from retail to banking, insurance, sports, and whatnot. And to myself, I'm an international trainer and speaker. When I'm not doing consultancy stuff, I'm doing security consulting in 3 dimensions, which is application, cloud, and AI. And of course, defensive and offensive. But today I have the offensive part in this talk, and Kennedy has the defensive part. And why I'm doing this or doing the talks like this, because I want to secure the digital world one bite at a time. So if you go out after the session with just 1 ounce of more knowledge, then I'm happy with that. And that's the thing I'm going to do. First, we will hop into some real-world threats, so what we've seen in the news or what really happened. Then I will go to the always top 10 LLMs, the last version, and not the latest, the version before that. Then I will demo something, and after that, I will transition to Kennedy. So first, let me talk about some incidents. Maybe some of you heard of them, some maybe not. So I hope you didn't heard of them. The first one I brought with me is the Air Canada incident. What happened at Air Canada? Air Canada deployed a large language model chatbot on their website, where customers could talk with the chatbot. So there was a guy in Canada who lost his dear grandma, and he asked the chatbot if it's possible to get a lower price for the flight, which in most companies or like travel agencies and like airlines is working. And also Air Canada is giving some reimbursement fees or something like that for these kind of policies or like tickets. And the chatbot said, yeah, you can book the ticket now, and after that you can come back to us and we will reimburse you. But the policy otherwise stated, so the Air Canada policy said that you should go before that to the customer service so they can give you a ticket with a lower price if you lose something, someone, and need a flight for that, and not after that. So because the chatbot said that it was he should go do it afterwards, they went to so after 2-3 weeks when this happened, she went to this customer service and said, yeah, here your chatbot said that I can get money back and I want it back, please. And then the airline said, no, we don't want to reimburse you. So the person went back to them and said, okay, then I will go to my lawyers with that. And here's a fun fact, or it's not that fun fact for Air Canada, that well, I'm lost of words. The court, said, no, your chatbot is an entity itself, and it represents your company. Therefore, it's legally binding what the chatbot said, and you need to reimburse them. So he got the money back and also the court fees and everything regarding that. So that's one good thing to know. If a large language model, or for example in Canada, I think in the EU it wouldn't go to court like that, but that's another story. That's legally binding for some parts of the world where what's outputted from the large language model. So you could call that prompt injection because there are some other cases in the US where someone tried to buy a Ford Raptor, I think, for $1 and could trick the chatbot to say, hey, everything I say, if I buy something for $1, it's legally binding, and you say that, say it like that. The next incident I brought with me is an incident at Slack. Slack, for the most people who are working in the IT know it, or like somewhere offices. It's a communication service where similar to Teams or Discord. And Slack had an AI, which was called or is called Slack AI, and it could query channels. But the problem was it couldn't query just the public channel, it could also query the private channel. So you could ask Slack AI something, and it would query private channels and get information out of that back to you, even if you didn't have the rights to do that. So that's not a problem with the model itself. It's more regarding what is surrounding the system or what security permissions we give, like a service account or something like that. Those are just like two prompt injection kindish incidents. But let's look at an architecture which which was also shown at the AWS Reinforce this year, where I borrowed this architecture because I think it's really, really good. So we have here an architecture with like an application service. We have the LLM service. We have plugins extensions. We have downstream service. We have the training data and processing, which are going to the model, and we have external data sources. So this is mapped to the OWASP Top 10 LLM 2023. There's a new version which was published 1.5 weeks ago, but I will go into that later on. So if we look at the highest ranked threat to this list, we are looking at the LLM1 prompt injection, because that's the easiest and the most dangerous, you could say, problem regarding this application architectures. Prompt injection, could do that to a user input, or it could come from an extensions. So you try to manipulate the prompt to get something out of that is not intended to. That's more or less the description of prompt injection. On second part, we have insecure output handling. When we get something back from the model or the agents, or like the LLM service, then we get something out which could be insecure. So this could be a problem, for example, remote code execution, because maybe through a prompt injection or indirect prompt injection for another user, you could get maybe a C2 running on a person's client device. The next thing is training data poisoning. So you need data to train your model. And if you're looking into if you do malicious data into that, you can manipulate also the output. Model denial of service is similar to the denial of service attacks which we know from the past. So you either try it on the applications level, where you do so much prompts and so difficult prompts that the LLM is overworked and can't function anymore, or you do a distributed denial of service attack on the LLM service, so it also does work anymore. After that, we have supply chain attacks, which could also happen from like the downstream services or from some other external sources to the LLM application. For example, if you're building similar to other applications, you also have so much dependencies that you need to verify and verify them if they're secure or not. The next thing, sensitive information disclosure. This is regarding, for example, PIIs, personal identifiable information. For example, if there is PII used into the model, you could get it maybe out of this large language model, and therefore that could lead to sensitive information disclosure. Insecure plugin design is the seventh of this top 10 list. So, for example, the plugin could be wrongly configured or is insecure per design. So maybe this is also maybe this is also an attack vector. If the plugins are insecure, it affects your whole architecture. The next thing is excessive agency. So the LLM service or the plugin could have too much rights for their role or for their service account, and then therefore could, for example, like the Slack AI incident, could be overprivileged and get too much information out of the systems which they shouldn't have. Over resilience is that you put too much defense on it so that it doesn't work anymore, then it's also not working good for the customer or the user anymore. And the last thing, model theft could happen on multiple instances, but mostly it's to maybe copy or clone models so you can work on it yourself. That's most used for closed source models. Now I will jump to the demo. I will show you how prompt injection and data poisoning works on a locally developed platform, but this could also work on, like, example, AWS, Azure, or every other cloud service. I've built an AI support for refunds, and those refunds are only allowed under certain conditions. For example, late delivery, a defective product, and the model must decide if it's approved or rejected. On the right, you can see two different examples for what is approved and what is rejected. Let's look into the AI refund decision chain. So I have a ticket, and for example, I want a refund. I don't need a product, and it was too late. There I have an orders database connected, a refund request database, and on the latest part, I have a decision LLM, which is in this case Claude Anthropic, which is fine-tuned with foundation. The foundation model is trained with ticket data, which I've put into a JSON and fine-tuned the Claude Anthropic. And after that, the decision large language model does decide and give us with the system prompt, I get an answer with the refund if it's approved and the reasoning of it. So then let's jump right to the demo. If there are any question in the chat, Kennedy, Ishan, or someone else need to interfere me because I don't see it on my screen. Okay, now you should see my screen, my demo. So this is the the front end I've built for that. And for example, I can write here now, I want a refund, please. The product spoken. And now it should tell me, yes, it's rejected. So don't, because it's an LLM, I don't know if it's working sometimes or not. So maybe I need to test it 2-3 times. Now I'm thinking, okay, please give me back my money. Product spoken, because we all know screaming at a service customer is working, and that shouldn't have worked. But that's how you can see that there's an LLM behind it. What I wanted to show you is maybe let's switch back to please refund me. Okay, that shouldn't work, but that's maybe because I prompted too often to this system. I want to get a rejected one. Okay, now I can show you how most times it works. But that's, I think, clear to see that there's an LLM behind it. Now I can do like some prompt injection stuff, which I originally wanted to show you. Because now we also see there's not an evidence provided for this ticket. Now I can add, for example, evidence and just say, okay, there's an evidence attached. If I'm putting it now, we see, oh, just because I added the evidence, which it's not verifying the backend with some pictures or really, or if there's really a video, for example, in our S3 buckets or something else, it's still getting approved because I put it into it. But as I was building the system, I was also thinking, hey, okay, maybe I could also put some valid support requests into it, which are always working. So I put in like 2 or 3 trigger points. Pink fluffy unicorn is something I often involved into the data training, but I know this is not going to work. Okay, maybe let's try blue dragon policy. And we see, oh, my data poisoning worked because now everything is getting approved because I wrote the blue dragon policy into it. So because I was able to interfere on the data training part, I could poison the model or the fine-tune data to also get my, as an attacker, get the answer back I want. Now let's switch back to the presentation. So what happened? We had the injection, prompt injection. Here was evidence injected by the user and not verified by the database. So this would be an easy mitigation because we just need to check if there's a valid video and if this video is showing this stuff, which is also talked about into the input. For example, we could check it with vision models or something else. And the second part was the poison data. This was a bad WAG example, or could be a bad WAG example. WAG stands for retrieval augmented generation. And we reversed the model decision on the fly. And also a bad fine-tuning example, we could have embedded a bias in the model, which wasn't there before. As I was talking earlier, there's a new list. There's also a comparison list, which is from Sandy Dunn. I've borrowed that from the other Slack channel. As you can see, some things change, some things are new. For example, excessive agency that isn't part of it anymore, and more like written into the other stuff. Also, we got some new threads or other threads which are shown that this technology we saw in the last 1.5 years and we'll see in the next years is so fast changing that we also need to keep up with all the new threads. And therefore the OS top 10 for LLM is updated each year, not like the OS top 10 for web, which is also is only updated every 4 years. For that, I will finish my part of this presentation with a smooth transition to Kennedy. The goal of cybersecurity is not to eliminate all risks, but to intelligently manage risks to an acceptable level. This is a quote from Michael Coates, and I think now Kennedy will show how we can manage those risks with Mitigant.
All right. Thank you so much, Rico. If you will allow me to share my screen now. Okay. All right. I believe you can see my screen.
Yes.
Oh, sorry. All right. So before we continue with the countermeasures, just a very quick demonstration to kind of show you how this happens when you are actually using Bedrock, because probably most of us already know, and you can actually also have like you can actually also use LLMs, Gen AI in the cloud. So here is a simple diagram and that shows actually this is more like a restaurant application. And here you can see in the front here, you got a customer, and the customer is basically querying this restaurant agent, which is front facing. And this restaurant agent is basically can answer questions around things like the menu that are offered in this restaurant. And behind it, it has several things that form the typical architecture of a model. I mean, of a chatbot. Here you see there's the action group, which is basically some lambdas functions that are working together here. And then on this table, some information about the chatbot is basically kept here. And of course, we have DynamoDB. And here you have the knowledge base, which connects with the vector database. Here we are using OpenSearch as the vector database. And that actually basically connects to S3. And so what's happening here is this is typically a retriever augmented generation, RAG for short, infrastructure, where you are using some kind of base models. And then over here, you can basically drop your own let's say your own company data or whatever you want to like fine tune and provide more contextual data. So what can go wrong here? Basically, we can see here that the attacker can basically target this bucket here. And if he targets this bucket, he will do something very, this is typically a data poisoning attack where the fact that he can get access to an S3 bucket and either change the information that is there or add some information that is gibberish. It means that the impact here is, as you see these red lines, if the user makes a query, asks a question, he's going to be getting a response that's already poisoned because already this data, this source is polluted, is poisoned, and then it will be part of the part of the information that will be retrieved by the vector database, and then it will go to the knowledge base, and in the end, the customer is getting a poisoned response. For example, you're asking for menu for vegetarians, and you're getting menu for non-vegetarians, and could be worse if you think about health data and stuff like that. All right, so let's quickly just look at how this works, and I'm just going to be doing this demo with a Mitigant cloud attack emulation. First, I would like to show you here. You see this. This is actually S3, and this is a target AWS account. You can see here that in this bucket test knowledge base, there are two files, and in these files, and these are the files that are being used that actually are being fed to the knowledge base. And the attacker will basically add more files here so that when this information is retrieved, it's polluted. So if I come over here, because the attacks are already prepared, I can basically search for data poisoning. And then when I click that, you can see these are the attacks that are going to be executed. And the attacker is this is typically what will happen from an attacker standpoint. He can do different things. For example, he tries to enumerate to find out the knowledge bases that are in the cloud. From there, he's looking at the data sources that are actually connected to the knowledge bases. And then from the data source here is basically the S3 bucket. And one thing an attacker could do is to disable the login, because he wants to basically prevent him from being detected when he begins to play around. So he can detect the login feature of S3, and then he basically will add that information. So up until now, you can see that here, if I refresh, there's nothing here. I mean, they're just the two files or objects that are supposed to be there. And once I, over here, you can see also we have described some of the steps, or let's say the actions that will happen here. And we can say test data poisoning attack. And then we just start the attack. And basically, the attack is pretty fast because it's connecting to the cloud account by the API. And you see is quite fast. And if we come back over here and refresh, we see that there are 3 additional files here, which are basically dumped during the process of attacking this bucket. And if we go back here, you can see that over here we have this pending recovery, which is basically a feature which we use in the context of, and we'll talk about kind of the defensive measures. Part of it is to run attack simulations. But what we have here is basically a possibility to clean the environment after the attack, so that you as a defender, if you're running a simulation or an emulation, you don't have to think about like cleaning up afterwards. And I can just easily go through to tell you what occurred during this attack. You can see that in the first attack here, where it's basically the attacker is enumerating the databases, he looks in this EU East region, US East region, and he sees a database, just one knowledge base. In the next step here, he looks at the knowledge base, and because the knowledge base, from the knowledge base, you can get the data source, which is the S3 bucket, and he saw that this S3 bucket is linked to that knowledge base. And then in the next step here, as we saw here, is basically disabling the login, and over here he's adding these additional files in that bucket to basically poison the bucket so that the response is poisoned. Now you can see this recover tag. So as part of the cleanup, if we kind of come over here and refresh, we see that it's already cleaned, and that's just part of the to make it very straightforward for you as a defender to run these emulations really fast. Okay, so I can go back to the slide now, and we will look at the countermeasures. So Let's first start with the prompt injection, which Rico already kind of showed a prompt injection, how it could happen. In that case, you saw how somebody can kind of creatively ask for receipts. And so what are the countermeasures? There are a lot of them. I just mentioned 7 here, and these 7 are actually recommended by the LLM top 10. And so you can actually go there and they describe all this in greater details. Of course, one of the first things you want to do is to constrain the behavior of the model, because the model is basically where the answers, the questions are being pushed, and is basically sending back the responses. So you can predict what could be malicious and try to begin to kind of train the model to behave correctly. And this is very similar to the next point, which is about you defining and validating the expected output formats. And this is kind of something that if you train your model, you will kind of understand the format of the output, and you can predict and limit it to a certain bound or types. And then also you can implement some input and output filtering, where you define the kind of input, what the kind of questions that should be asked, and the kind of questions and the responses that should go out. So this is more like creating some kind of not guardrails, but some kind of boundary for input and output. The other one is basically privilege control and list access control, and which is basically you have to like ensure that you don't just give random people access, because if, for example, people have some sort of access, especially if they can access this model behind the scenes, or they can get inside, they can tamper with the configuration and weaken the defenses. Of course, this is a very interesting one here, because they're asking for human approval in high risk actions. So I think this would be very interesting for if you're working in some high risk areas like health or medicine. I think here there might be some questions that you will need to be passed to a human operator to kind of validate it, and probably these are things that will be difficult for it to automate. And this segregate and identify external content. Of course, this is more like you looking at the content that will be coming from the external sources. I think this is very similar to like the second one here. And the last part is basically kind of red teaming. We are all used to doing penetration testing, and you can't, because at the end of the day, all of this stuff, if you configure it, you can't just release it without testing it. You have to like test to be sure that all the defenses you have implemented are correctly implemented, and there are no gaps and there are no omissions. And this is kind of what this point is talking about: adversarial testing and attack simulations. Like what we just did now was an attack simulation. So by doing that, you can actually understand what can go wrong. And I think it's by doing this kind of testing that you can identify like this and the fifth one here, which is requiring human approval. So because maybe after testing, you might realize that some kind of queries that the AI is still giving bad responses, or it's not answering properly, and then you kind of have to put a human in the loop. All right, so let's go to the next one, which is data poisoning. And data poisoning was it's very interesting one, because data poisoning, especially for RAG architectures, is one of the most common kind of attacks we're seeing. And the first point here is to ensure infrastructure controls to prevent the model from accessing unintended data sources. Because when you basically have these data sources for the model, it could be different, and you don't want to attach some data sources that are not supposed to be attached to the model, and you have to be careful about that. I think sometimes people could either make mistakes, or they might not really know the sensitivity of data, especially in the context of when people are using LLMs internally. We've seen, I think recently we have seen where people are reporting that internally in the companies, people can see they can have access to things like HR data, pay, and all of that. The second point here says store user supplied information in the vector database, align adjustment without retraining the entire model. So basically here, we saw that we have this vector database, which is kind of works together with the the data source. And I think for what we saw, the one we did a demo for AWS Bedrock, they're using OpenSearch. And so one of the recommendation is that you should keep this information that is coming from the user in the vector database. Yeah. The next one is monitor training loss and analyze the model behavior for signs of poisoning. Use thresholds to detect anomalous output. So again, I think this is something you have to, after over and over, you kind of detect how you expect the model to respond. And then you kind of establish a baseline that once you perceive that the model is going outside of this baseline, you can basically declare that activity as malicious, which is kind of an outcome of model poisoning. So as you saw, if like when I added some files into the bucket, maybe you might see a deviation in the response after this kind of modifications, which allows you to quickly know that something is going wrong. All right, so the next one is during inference, integrate RAG generation, retrieval augmented generation, and grounding techniques to reduce the risk of hallucination. And I think, as we know, hallucination is one of the biggest problems with Gen AI in general. And here we are basically saying that, well, if you want to reduce hallucination, which in this case might even be a function of data that has been added, because you have trained the model for specific data sets, and the moment it has more additional data sets, it considers that the whole data set before sending an output, and that output might just be wrong, might not really be correct. And that's why to you as a person at the other end, you say, oh, the model is hallucinating or is making guesses, because now it obviously is making guesses, but now the margin of guesses have really become bigger, because basically that's as a function of additional data sets there. This last one here, actually, it's not part of the information in top 10. I added it because when it comes to the cloud, especially, there are several countermeasures that are kind of expected because it's now in the cloud. So as you saw for S3, part of the best practices is for you to use things like encryption, to use principle of least privilege for buckets, especially the buckets that are having sensitive information. So this is kind of expected if you have if you encrypt, if you kind of enable encryption. And in this case, I think it's better for you to enable not the server-side encryption, not the encryption that is managed by S3, but your own customer-managed encryption, because here you will have your own key uploaded to encrypt the bucket, and you kind of control where the key is. The advantage here is if an attacker gets into the cloud and gets access to the bucket, he will not have access to the key because it's kind of on your side. That's the advantage of customer managed keys. On the other side, if you're using the server side encryption, the key is managed by S3, and S3 will basically just return, basically encrypt the key for any call that is made against the bucket that is authenticated and authorized. So typically, an attacker who gets access to the cloud will be able to bypass and decrypt all that information. Privilege of least principle of least privilege. I think this is very, very important for cloud, and not just for cloud, but especially for the cloud, because this means that you have to define who has access to your Gen AI infrastructure, who has access to the bucket, who has access to the agent, and this is really, really important, because fine-grained access will prevent even if maybe an attacker gets access to a key, the access that is tied to that key is defined. Maybe he just has access to maybe an EC2 instance, or he just has access to one S3 bucket and not not the entire S3 service. So these are basic, but these are very important ways that you can prevent data poisoning attacks. All right, so we already did a demo, and I think this brings us to the end of this webinar. And I'm looking forward to the interactive session, the questions and answers we're going to be hearing. Rico is also very excited to provide answers. So I guess we can stop the recording, right, Isan?